Hello everyone, welcome to Python Challenge for All. Okay, so today's topic is Monte Carlo method for approximating pi. As you know, yeah, pi is something like 3.14 something. So we use Monte Carlo method, a kind of numerical method, to approximate pi. So what is the idea? The base idea is that randomly scatter points inside a unit square, okay, with side length of 1. And then for each point, check whether it lies inside the quarter circle in it or not. So it looks like this, okay? So there's a square with side length of 1, and there is a quarter circle of radius 1. So, and we scatter many points, red points in this square. So, and we can kind of count the number of points within this quarter circle area. So compare the distance. To do that, we need to compare the distance from the origin with the radius, okay? Origin of each point. The, so measure or calculate the distance from the radius here. Okay. So for each point, you know how to calculate the distance of it, right? So to do that, we use mathematics to estimate the distance and then check whether it is inside the circle or not. Okay, let's go and start with it. So it's like this. Make a new box saying it Monte Carlo. It's a city in, say, Nice, near Nice, okay? And then what we need is, one thing we need is import random, okay? Random package. And also we need, as last time, matplotlib dot pyplot as PLT. Okay, as I said, this is a standard way. And so we need to do point. So point, let's try, for example, in the beginning to scatter NN points like 2000 and see how it looks like. Okay, so for I in range NN, we randomize, we make a random number between a floating random number between 0 and 1. So that can be done by random dot random. And this will make a random variable of between 0 and 1. Okay, good. So from that point, we can calculate the square of the distance as x squared plus y squared. This is by the Pythagorean theorem, right? So if this d2 is within the range of 1. So here, yeah, if d is, okay, if d is smaller than 1, it is in the circle, okay? And otherwise, it will be outside of the circle. So let's visualize that by using different colors for each point. To do that, okay, in that case, we can make, yeah, Let's see. Okay. Let's see this way. Okay. So color. Okay. Let's do it this way. Color equals red if the distance is smaller than 1. Otherwise, it will be blue. Okay? And let's plot the points as PLT dot plot scatter. That's a way to scatter points. X, Y, and size of 2 with color. Okay? Let's see how it looks like. After that, we can see that PLT dot show. Let's see how it looks like. X squared, x times x plus y times y, or x squared plus y squared. So let's run it. It might take a little time. So okay, now it's done. Let's take a look. Okay, it's a bit. Let's shrink a bit. So it looks like, okay, good. Some points are within the radius, just like we drew this way, okay? Of course, if you want, you can add one more line before PLT, PLT dot GCA dot set aspect equal to make it a little more square, real square. But anyway, okay, let's run it and see how it looks like. Okay, this is what we get. Now it looks a little better. Now the X and Y scale is the same, so it's real square. So this is what we want. We want to count the number of reds in contrast to red plus blue, and that will give us the estimate of pi. Okay, let's continue that. So from here, we can improve accuracy by increasing the number of um, points to try. So because the drawing process takes time, maybe we don't want this. So we will comment out the drawing process. And then instead, we will increase the number to say 10 to the times of say 7, okay? 10 million points. And for that, maybe we will count the number of if, okay? So we count the number of points, okay? We initialize the counter as 0. And if d2 is smaller than 1, 1.0, count up as plus equal 1. Okay? So at the end, we will print out the number of dn, and then, nn, and also cc, and ratio of cc times 4. And let's take a look at it. Okay? We repeat it 10 million times and count the number of times that point is within the radius of a circle. Okay? Falls inside the quarter circle. And we can use it. You can use your mathematics to see that if you multiply this by 4, it should be equal to, it should approximate the value of pi. So let's run it yourself and let's check when it's back. Okay, it was quicker than I thought. So out of 10 million points, 7.85 million points were within the circle. So if we multiply it by 4, multiply the ratio by 4, we get 3.14 something. So if we increase the number to say 100 times, 100 million, for example, you can get closer approximation. You can try yourself and see how it gets closer to the real value of 3.1415 something. But of course, it takes time. So you can enjoy yourself, try to find better approximation of pi using this very simple code. And also you can enjoy visualization of it if you want. Okay, that's all for today. Please be sure to come back next time. Bye bye.